what is arithmetic mean, and we are going to find out how to find the arithmetic mean of the given sequence. First, let us define what is arithmetic mean. When we say arithmetic mean, it is the term of the arithmetic sequence that is between two given terms are called arithmetic means. Now, in order for us to understand what is arithmetic mean, let us familiarize ourselves to the formula of arithmetic sequence. That is a sub n equals a sub 1 plus n minus 1 times d, where a sub n, that is the last term, a sub 1, that is the first term, n will be the number of terms, and d, that is the common difference. So let's have an example. Number 1, what is the arithmetic mean between 85 and 95? So let us write the given 85 blank and 95. There are two different ways in finding the arithmetic mean of 85 and 95. First, you are going to add 85 and 95 and then divide by 2. So that is 85 plus 95 divided by 2. So that is 180 divided by 2. So the arithmetic mean is 90. Or you can use the formula for arithmetic sequence, that is a sub n equals a sub 1 plus n minus 1 times d, wherein a sub 1 will be the first term, that is 85, and then a sub n, that is the last term, which is 95, and then n, that is 3, because we have 3 terms, 1, 2, 3, and we are looking for the common difference. Now, let us substitute the given value to the given formula. So a sub n will be 95, so that is 95 equals a sub 1, which is 85, plus the value of n, which is 3, minus 1 times d. Let's simplify. We have 95 equals 85 plus 3 minus 1, that is 2 times d, that is 2d. And then let's move 85 to the side of 95. So that is 95 minus 85 plus equals 2d. And then 95 minus 85, that is 10, equals 2d. To find the value of common difference, simply divide by 2. Cancel. So the common difference is 5. So always remember, to find the next term, simply add the common difference to the first term or last term if you are going to find the arithmetic mean. So in this case, 85 plus 5 is 90. So the arithmetic mean of 85 and 95 is 90. What about number 2? What is the arithmetic mean between negative 12 and 4? So we have negative 12 blank and 4. So we are looking for a number between negative 12 and 4. So again, let's add negative 12 and 4 plus 4 over 2. So negative 12 plus 4, that is negative 8 over 2. So negative 8 over 2, that is negative 4. So the arithmetic mean is negative 4. Or you can use the formula. We have a sub n equals a sub 1 plus n minus 1 times d. So a sub n will be the last term, which is 4. A sub 1 will be the first term, that is negative 12. And then n, that is 3, because we have 3 terms, 1, 2, 3. And then let us substitute this given to the formula. We are looking for d. So we have 4 equals a sub 1, that is negative 12, plus n, that is 3, minus 1 times d. And then we have 4 equals negative 12 plus 3 minus 1, that is 2, times d, that is 2d. And then move negative 12 to the side of 4, that is 4 plus 12 equals 2d. And then 4 plus 12, that is 16 equals 2d. Divide both sides by 2. So the common difference is 16 divided by 2 is 8. So to find the mean, simply add the common difference to the first term. Negative 12 plus 8, that is negative 4. Let's have another example. On number 3, insert 4 arithmetic means between 38 and 98. First, let us write the given. We have 38 and we are going to insert 4 arithmetic mean. That means we are going to insert 4 numbers. 1, 2, 3, 4. And then we have 98. In this case, we are going to use the formula of arithmetic sequence. That is a sub n equals a sub 1 plus n minus 1 times d. Let us determine first the given. A sub n is the last term, which is 98. And then a sub 1 will be the first term, that is 38. And then n, that is 1, 2, 3, 4, 5, 6. So n is 6. And we are looking for the common difference. Now, let us substitute this given to the given formula. A sub n will be 98 equals a sub 1 is 38 plus n, that is 6, because 1, 2, 3, 4, 5, 6, we have 6 terms. 6 minus 1 times t. And then let us simplify. 98 equals 38 plus 6 minus 1, that is 5, times d, that is 5t. This time, let us move 38 to the side of 98. So we have now 98 minus 38 equals 5d. And then 98 minus 38, that is 60. Okay, so 98 minus 38, that is 60. Then 60 equals 5d. And then to find the value of d, that is, we're going to divide by 5. So the common difference is 60 divided by 5 is 12. Now, to find the 4 arithmetic mean between 38 and 98, we are going to add the common difference to the first term. So that is 38 plus 12, that is 50. And then 50 plus 12, that is 62. 62 plus 12, that is 74. Then 74 plus 12, that is 86. Then 86 plus 12 is 98. So 98 will be the last term. So the arithmetic mean, 4 arithmetic mean between 38 and 98 are 50, 62, 74, and 86. What about number 4? How do we find the 5 arithmetic means between negative 15 and 3? First, let us write the given. We have negative 15. And then we are going to insert 5 arithmetic means between negative 15 and 3. So that's 1, 2, 3, 4, 5. Then last term is 3. So again, we are going to use the formula for arithmetic sequence. We have a sub n equals a sub 1 plus n minus 1 times d, where a sub n will be the last term, that is 3. A sub 1 is the first term, that is negative 15. And then n will be 1, 2, 3, 4, 5, 6, 7. We have 7 terms. And then d, we we are looking for the common difference. Now, let us substitute this given to the formula. A sub n will be 3. That is the last term. Equals a sub 1, that is negative 15, the first term. Plus 7, that is 1, 2, 3, 4, 5, 6, 7. We have 7 terms. Minus 1 times d. Then after that, let us simplify. We have 3 equals negative 15 plus 7 minus 1 is 6 times d is 6d. And then move negative 15 to the side of 3. We have 3 plus 15 equals 6d. And then 3 plus 15 is 18 equals 6d. Then divide both sides by 6 to find the common difference. So the common difference is 18 divided by 6 is 3. So to find the 5 arithmetic means between negative 15 and 3, simply add 3 to the first term. So we have negative 15 and we are going to insert 5. 1, 2, 3, 4, 5 and then 3. So we have here negative 15 plus 3 is negative 12. Negative 12 plus 3 is negative 9. Then negative 9 plus 3 is negative 6. Negative 6 plus 3 is negative 3. Negative 3 plus 3 is 0. So therefore, the 5 arithmetic means between negative 15 and 3 are negative 12, negative 9, negative 6, negative 3, and 0. What about for number 5? If the third term of the arithmetic sequence is 13 and the ninth term is 37, write the first 9 terms of the sequence. So first, our given is 13, that is the third term, and then 37, which is ninth term. So we have here 1, 2, then third term, that is 13, 4, 5, 6, 7, 8, 9. The ninth term is 37. So in order for us to write the first 9 terms, let us use the formula for arithmetic sequence. So we have a sub n equals a sub 1 plus n minus 1 times d. Now let us identify what is the last term, first term, and the value of n. So the last term is 37. And then a sub 1, since we do not have an a sub 1, 13 will be our first term. So that is 13. But the number of term will be 1, 2, 3, 4, 5, 6, 7 will be 7, not 9. Because since we don't have a first term, we are going to write 13 as our first term and 37 will be our last term, but the number of terms will be 7. We are going to disregard first the first 2 terms before 13. So 13 will be the first term. 1, 2, 3, 4, 5, 6, 7. Now, let us find the common difference. So we have a sub n, which is 37, equals a sub 1, which is 13, plus n, that is 7, minus 1, times the common difference. So 37 equals 13, plus 7 minus 1 is 6, times d, that is 6d. And then after that, move 13 to the side of 37. 37 minus 13 equals 6d. What is 37 minus 13? So we have here 24 equals 6d. So divide both sides by 6. So the common difference is 24 divided by 6, that is 4. So this will be our common difference. Since we already know what is common difference, let us write the first 9 terms in the sequence. Since the third term is 13, let us write first the first 2 terms before 13. So to find the first two terms before 13, we simply subtract 13 minus 4. 13 minus 4 is 9. 9 minus 4 is 5. So therefore, our first term is 5, second term is 9. What about the fourth term? So fourth term is 13 plus 4, that is 17. Fifth term 17 plus 4, which is 21. 6, there is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 21 plus 4 is 25. 25 plus 4 is 29. Then 29 plus 4 is 33. And then the ninth term, which is 37. So therefore, the first 9 terms in the sequence is 5, 9, 13, 17, 21, 25, 29, 33, and 37. What about number 6? If the fourth term of arithmetic sequence is 24 and the 12th term is 56, write the first 7 terms of the sequence. First, let us write the given. So since the fourth term is 24, we're going to have 1, 2, 3, 4, which is 24, the fourth term. Then we are going to have until 12, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 12th term is 56. Now, to write the first 7 terms of the sequence, let us use again the formula for arithmetic sequence, which is a sub n equals a sub 1 plus n minus 1 times d. So let us identify the given. So we have here a sub n will be the last term, which is 56. The number of terms, so since we don't have a first term, so this will be our first term, that is 24, but we change the number of terms or number of n. 1, 2, 3, 4, 5, 6, 7, 8, 9. So n will be 9 because our first term is 24. Now, let us write the given. So we have a sub n, which is 56. 56 equals a sub 1, that is 24, plus n minus 1, that is 9 minus 1 times d. And then we have 56 equals 24 plus 8 minus 1 is, or 9 minus 1, that is 8d. And then move 24 to the side of 56. So 56 minus 24 equals 8d. Then subtract 56 minus 24, that is 32, equals 8d. Divide both sides by 8. So our common difference is 32 divided by 8, that is 4. So our common difference is 4. Now let us insert the first 7 terms. So we have 1, 2, 3, 4, 5, 6, 7. Since the fourth term is 24, 1, 2, 3, 4 is 24. So let us add 24 or 4 to the 24 to find the 5th, 6th, and 7th term. And we are going to subtract 4 to the 24 to find the first 3 terms. So let us subtract. 24 minus 4 is 20. 20 minus 4 is 16. 16 minus 4 is 12. So the first 3 terms is 12, 16, 20, 24. And then the next 3 terms after 24 is 24 plus 4 is 28. 28 plus 4, 32. 32 plus 4 is 36. So therefore, the first 7 terms of the sequence is 12, 16, 20, 24, 28, 32, 36.
Arithmetic sequence. A sequence which consecutive terms have a common difference is an arithmetic sequence. The sequence a sub 1, a sub 2, a sub 3, a sub n is arithmetic if there is a number d such that a sub 2 minus a sub 1 equals d, a sub 3 minus a sub 2 equals d, a sub 4 minus a sub 3 equals d, and so on. The number d is the common difference in the arithmetic sequence. Let us now find the formula for the general or nth term of any arithmetic sequence. Let us denote the difference of two consecutive terms called common difference by d. The following are some of the first few terms of the sequence. A sub 1, a sub 2 equals a sub 1 plus d, a sub 3 equals a sub 2 plus d equals a sub 1 plus d equals a sub 1 plus 2d. A sub 4 equals a sub 3 plus d equals a sub 1 plus 2d plus d equals a sub 1 plus 3d. A sub 5 equals a sub 4 plus d equals a sub 1 plus 3d plus d equals a sub 1 plus 4d. Rule. Formula for the nth term of an arithmetic sequence. The nth term a sub n of an arithmetic sequence with first term a sub 1 and common difference d is given by a sub n equals a sub 1 plus n minus 1 times d. Example 1. Nth term of an arithmetic sequence. Write the formula for the nth term of the given arithmetic sequence. A 11, 18, 25, 32, 39, B 9, 1, negative 7, negative 15, negative 23. Solution. 8. Each term is 7 more than the previous term, so d equals 7. Since a equals 11, the nth term is a sub n equals a sub 1 plus n minus 1 times d equals 11 plus n minus 1 times 7 equals 11 plus 7 n minus 7. A sub n equals 7 n plus 4. Check. Substitute a few terms. A sub 1 equals 7 times 1 plus 4 equals 11. A sub 2 equals 7 times 2 plus 4 equals 18. A sub 3 equals 7 times 3 plus 4 equals 25. D equals 1 minus 9 equals negative 8 and a sub 1 equals 9. The nth term is a sub n equals a sub 1 plus n minus 1 times d equals 9 plus n minus 1 times negative 8 equals 9 minus 8n plus 8. A sub n equals 17 minus 8n. Check a few terms. A sub 1 equals 17 minus 8 times 1 equals 9. A sub 2 equals 17 minus 8 times 2 equals 1. A sub 3 equals 17 minus 8 times 3 equals negative 7. Example 2. Nth term of an arithmetic sequence. Find the 15th term of the arithmetic sequence 16, 20, 24, 28, 32. Solution. Note that a sub 1 equals 16, d equals 20 minus 16 equals 4, and n equals 15. A sub n equals a sub 1 plus n minus 1 times d. A sub 15 equals 16 plus 15 minus 1 times 4 equals 16 plus 14 times 4 equals 72. Example 3. Nth term of an arithmetic sequence. In the arithmetic sequence 6, 12, 18, 24, 30, which term is 120? Solution. Find n when a sub n equals 120. Let a sub 1 equals 6, d equals 6, and a sub n equals 120. A sub n equals a sub 1 plus n minus 1 times d. Formula for the nth term of an arithmetic sequence. 120 equals 6 plus n minus 1 times 6. Substitute the known quantities. 120 equals 6 plus 6n minus 6. Apply the distributive property. 120 equals 6n. Combine like term. n equals 20. Divide both sides by 6. Thus, 120 is the 20th term. Example for nth term of an arithmetic sequence. Solution. Find the common difference, d, by substituting a sub 1 equals 11 and a sub 7 equals 59 into the formula. A sub n equals a sub 1 plus n minus 1 times d. A sub 7 equals a sub 1 plus 7 minus 1 times d. 59 equals 11 plus 7 minus 1 times d. Replace a sub 7 with 59 and a sub 1 with 11. 59 equals 11 plus 6d. Simplify. 48 equals 6D. Subtract 11 from both sides. D equals 8. Divide both sides by 6. Find A sub 18 by substituting A sub 1 equals 11 and D equals 8 in A sub n equals A sub 1 plus n minus 1 times D. A sub 18 equals 11 plus 18 minus 1 times 8 equals 11 plus 136 equals 147. Example 5. Real life application. The conference hall has 20 rows of seats. The first row contains 20 seats. The second row contains 22 seats. The third row contains 24 seats, and so on. How many seats are there in the last row? How many seats are there in the conference hall? Problem solving tip. We can follow Polya's method for steps in solving word problems. Step 1. Understand the problem. Step 2. Devise a plan. Step 3. Carry out a plan. Step 4. Lookbook. Solution. 8. We know that n equals 20. A sub 1 equals 20. A sub 2 equals 22. A sub 3 equals 24 and D equals 2. A sub n equals A sub 1 plus n minus 1 times D. A sub 20 equals 20 plus 20 minus 1 times 2. Substitute the known values. A sub 20 equals 20 plus 19 times 2. Simplify. Equals 20 plus 38 equals 58. Thus, there are 58 seats in the last row. B. Find the sum of 20, 22, 24, 26, 28, 58. 20 plus 22 plus 24 plus 26 plus 28 plus 30 plus 32 plus 34 plus 36 plus 38 plus 40 plus 42 plus 44 plus 46 plus 48 plus 50 plus 52 plus 54 plus 56 plus 58 equals 780. When many terms are to be added, more time and effort are needed. Let us find a shortcut to find the sum, S sub n, of any arithmetic series. Notice that there are two ways to obtain the terms of the sum S sub n. 1. Start with the first term A sub 1, and successively add the common difference, D. First term, second term, third term, next to the last term, last term. S sub n equals A sub 1 plus A sub 1 plus D plus A sub 1 plus 2D plus A sub n minus D plus A sub n. Equation 1. 2. Start with the nth term, A sub n, and successively subtract the common difference, D. S sub n equals A sub n plus A sub n minus D plus A sub n minus 2D plus A sub 1 plus D plus A sub 1. Equation 2. 3. Adding the two equations, we have S sub n equals A sub 1 plus A sub 1 plus D plus A sub 1 plus 2D plus A sub n minus D plus A sub n. Equation 1. S sub n equals A sub n plus A sub n minus D plus A sub n minus 2D plus A sub 1 plus D plus A sub point 1. Equation 2. 2x sub n equals A sub 1 plus A sub n plus 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 A sub 1 plus A sub n. N terms. Since the expression A sub 1 plus A sub n appears n times, we write this last equation as 2x sub n equals n A sub 1 plus A sub n. Dividing both sides of the equation by 2, we have the following formula. S sub n equals n over 2 times A sub 1 plus A sub n. Rule: sum of the first n term of an arithmetic sequence. Given the arithmetic sequence where A sub 1 is the first term and A sub n is the nth term, the sum of the first n term is given by S sub n equals n over 2 times A sub 1 plus A sub n. Using the formula S sub n equals n over 2 A sub 1 plus A sub n, the number of seats in the conference hall can be obtained as follows. S sub 20 equals 20 halves times 20 plus 58 equals 10 times 78 equals 780. Substitute the known quantities. Thus, there are 780 seats in the conference hall. Example 6. Sum of an arithmetic sequence. Find the sum of the following. A first 25 terms of the arithmetic sequence 18, 23, 28, 33, 38. B first 50 terms of the arithmetic sequence if the first term is 21 and the 20th term is 154. C first 18 terms of the arithmetic sequence which general term is A sub n equals 15 plus 8n. Solution. 8. First, find a sub 25 with a sub 1 equals 18, d equals 5, and n equals 25. Substitute all the known values. A sub n equals a sub 1 plus n minus 1 times d. A sub 25 equals 18 plus 25 minus 1 times 5 equals 18 plus 24 times 5 equals 18 plus 120 equals 138. Solve for s sub 25. S sub n equals n over 2 times a sub 1 plus a sub n, sum of the first n terms of an arithmetic sequence. S sub 25 equals 25 halves times 18 plus 138. Substitute the known values. Equals 1950. Simplify. Therefore, the sum of the first 25 term of the arithmetic sequence is 1950. B. Solve for the d using the formula a sub n equals a sub 1 plus n minus 1 times d. A sub 20 equals a sub 1 plus n minus 1 times d. 154 equals 21 plus 20 minus 1 times d. Substitute the known values. 154 equals 21 plus 19d. Simplify. 133 equals 19d. Subtract 21 from both sides. d equals 7. Divide both sides by 19. Find a sub 50. A sub 50 equals 21 plus 50 minus 1 times 7 equals 21 plus 343 equals 364. Thus, s sub 50 equals 50 halves times 21 plus 364 equals 25 times 385 equals 9,625. Therefore, the sum of the first 50 terms is 9,625.